Selecting the right nut or bolt to suit a particular thread should never be guesswork. If a bolt with the wrong thread is selected for a particular task, severe thread damage can occur, which can be costly and time-consuming to repair. During this video, you will be shown how to identify common bolt threads and how to identify common grades or strengths of bolts. Before you can correctly identify a thread, you must have an understanding of thread terminology. The main parts of a thread are the crest, the root, the thread angle, the pitch, the major diameter, and the minor diameter. Looking at a bolt, we can see that the main parts are the head, the shank, and the thread. When measuring bolts, the bolt diameter is measured on the shank, while the bolt length is measured from the shoulder to the end. This bolt is 50 millimeters long. There are two common types of bolt threads used in industry, ISO metric and imperial. The ISO metric bolts have a thread angle of 60 degrees. The common imperial bolt types are unified coarse, known as UNC, unified fine, known as UNF. Both of these have a thread angle of 60 degrees. There are also British Standard Whitworth, known as BSW, and British Standard Fine, known as BSF. These have a thread angle of 55 degrees. UNC, UNF, BSW and BSF threads are imperial threads, and they are measured using the inch or imperial scale. To identify a bolt thread, you'll require a micrometer, either metric or imperial, thread pitch gauges, both metric and imperial, a decimal equivalent chart, a tapping drill chart, and a set of imperial and British spanners. To identify a thread, the bolt diameter must be measured first. If you refer this measurement to a decimal equivalent chart, it can give you an indication whether the bolt is imperial or metric. After that, the thread pitch must then be identified. Care must be taken when using thread pitch gauges, as some metric and imperial thread pitches are very similar. Once the bolt diameter and thread pitch have been identified, the decimal equivalent chart and tapping drill chart are then used to identify the bolt. This bolt diameter is 0.387 inches. This would make it too big to be 3/8 of an inch in diameter, so there is a good chance that this bolt could be 10 millimeters in diameter. The reason that the bolt diameter is 0.387 inches instead of 0.393 inches, which is the 10 millimeter equivalent, is that an allowance is made in manufacture to allow a nut to glide easily onto the bolt. This bolt is in fact a 10 millimeter bolt, and the thread pitch gauge has identified that the thread pitch is 1.5. Metric bolts are only manufactured in standard sizes, such as 5, 6, 10, 14 millimeters, etc., while imperial bolts are usually manufactured in increments of 1/16 of an inch, example 1/4 inch, 7/16, 1/2 inch, etc. These two bolts have been identified as being 7/16 inches diameter and having 14 threads per inch. However, if I refer to the tapping drill chart, they could be either BSW or UNC. A projector would be the most accurate method of determining the thread angle. However, a practical workshop method to decide which bolt is BSW and which is UNC is to use a spanner. UNC and UNF bolt threads are measured across the flats. This is commonly called AF. The head of this 7/16 bolt fits a 5/8 inch AF spanner, so this bolt is UNC with a thread angle of 60 degrees. This bolt head fits a 7/16 BS or British Standard spanner, so the thread is 7/16 BSW with a thread angle of 55 degrees. In the case of the M10 bolt, a 16mm spanner will fit the head, as metric bolt heads are also measured across the flats. With a little practice, identifying standard bolt threads becomes easy. Now that you have been shown how to identify bolt threads, let's now look at the various grades or strengths of bolts. The method of grading and identifying bolt classes or grades is different between metric and imperial. The most common classes of metric bolts are Class 4, which are made from low carbon steel. This is a general purpose bolt, and you would probably find a Class 4 bolt on a timing belt cover. Class 7, which are made from high carbon steel, and which would normally be used in such areas as an alternator mounting bolts. Class 9, which are made from alloy steel. These bolts are strong and would be used in such areas as engine mounting bolts. You may also find a Class 10 bolt which can be identified by an O, or a Class 12 which can be identified by a 2. Both are made from alloy steel and can be found as head bolts on the Isuzu engine. Be sure you do not mix the classes of bolts. Seek assistance if in doubt. To identify metric nut strengths, the number 4 nuts are chamfered on one side only and are used on Class 4 and Class 7 bolts, while the number 7 nut is chamfered on both sides and can be used on either Class 7 or Class 9 bolts. They must always be used on Class 9 bolts. For imperial bolts, the two common grades are Grade 5 with 3 markings. These could be used as alternator mounting bolts. Grade 8 with 6 markings, which is a high tensile bolt. These are used in high strength areas such as the universal joint. Using a grade of bolt which is of lower strength than recommended can cause a failure resulting in serious damage or a fatality. Let us now sum up the steps needed to identify a bolt thread. Measure the diameter. Identify the pitch.